Welcome back to part 2 of this tutorial where we're going to apply the Unity job system once we've got our Perlin landscape up and running. So let's finish that code so we can get some Perlin heights over the top of that flat set of cubes. Go back into your code. We're going to go down below our create cubes and now add in our update. So the update method is going to look something like this. You can see that we start off with two values, an X offset and a Z offset. What I'm doing first of all is I'm going to create the Perlin noise relative to the position of that landscape object. So as you move that landscape object around the scene, it's going to scroll itself over the top of the Perlin noise algorithm and give you the effect of a scrolling landscape. So we'll do this way first. So start with your offsets. You need an X offset and a Z offset for the position of that landscape. This code is attached to that landscape, so it's getting its X position and then taking away half of the width that we're working with and the Z position and taking away half of the height. So it will position the landscape's transform object right in the center or above the center of that landscape. We're then going to loop around all of the cubes that we have and set their heights using a Perlin noise function. Let me just make this a little bit bigger to grab that Y offset on the end there. So again, we've got our flattened array of cubes, so we're just going to loop through all of those. We then work out our X and our Z values, and in this case we also need to know which layer we're working on as well. So we're grabbing hold of a Y offset, and these are the same equations that we went over in the previous video. With those now worked out, we can set the cubes according to their X and Z position. And then what I'm going to do with the Y position is just use that as a little bit of an offset from the Perlin, because a Perlin noise value generated at an XZ position is going to give you the same value over and over again. That's okay, we want that, but because you want cubes on different layers sitting nice and neatly underneath each other, we're just going to offset them by which layer that they're in. So that's why we need to work that out. Now the cube's transform is being set to a vector 3 of the X plus the X offset. So this is the offset that you get from moving your landscape around. We'll then use a generate Perlin height method that we're yet to write. We give it an X value and a Z value, and then it gives us whatever height that cube should be set at, plus the layer that it's on. And you'll see that come into play very shortly. And the third value for our vector position will be our Z value. So it's the Perlin heights that are being used just for the height value. The last thing I've got in this update is I've just really quickly programmed some of the arrow keys that will move your landscape object back and forth across the scene so that you can move it around to see the effect. You can also grab it in the scene with its axes and move it as well if you like. Now, last but not least, we'll add in a method that will calculate our Perlin height values. So this will be it here. It's a static float. It's called generate Perlin height based on the X and Z values that you pass through to it. Now, I won't go into all the math behind this. You'll need to look over the Perlin noise stuff in order to figure out exactly what's going on. But in this case, it is using the mathf.Perlin noise, so the built-in Perlin noise function that comes with Unity. You give it some little value, so a small X value and a small Z value, and it will give you back a height along its equation. And X and Z essentially need to be little tiny values. That's why I'm multiplying by this smooth here, which I've got set to 0. That's not 0, so it's 0.03, so it's a small value. And then once you get the noise value, multiplying whatever the result is up by a certain height. And this is kind of like your height scale that you can set. And then what am I doing here? I'm dividing it by 2. So I'm adding 2 lots of Perlin Noise together in order to generate a height. And if you have a look over some of the documentation of Perlin Noise and in fact fractal Brownian motion, you'll find that it is multiple Perlin noises added together, which will give you some really interesting landscapes that you use. But we're just keeping it simple for now. And then after I've got this height value, I'm returning the height and again ramping it up by 10. So you can't see any real heights happening on your landscape. This here is where you probably want to be playing around with that value, making sure smooth is little and maybe just keeping this height multiplied by 5 there. Okay, so that's being used back in the update, and that is all we need in our Perlin scroller. So with that in place, let's save it and go back and have a look. Okay, so back in Unity, we will now press play and you'll be able to see the Perlin Noise on your landscape. So I'll just zoom out there and you can have a look at it. Now, remember we programmed it so we can move around the arrow key. So if I click over in the game view and I use the arrow key, you can see I'm moving that along and it's following the mathematical function that is that Perlin Noise. And we can go in either direction. So it just keeps taking all of the cubes, looping through all the cubes and resetting their height based on the Perlin Noise at the position of their offset. Okay, the other thing is the number of layers. So if you go and have a look at here close up, I've got 2 layers in mine and you can see how they're matched nice and neatly together, each second layer. So that this is where that Y offset is coming in as far as calculating the layer so that it can move down whatever height is calculated. And the more layers, the deeper this will get. The reason in this case you might want multiple layers is if you just look up here, you can see that there's a few gaps appearing because of kind of the steepness value that's being generated. And you will then be able to see through. But if you have more layers that go deeper into your terrain, you then can't see through. Now, having said that, let me just say it again. This is not the way to generate a endless cubic landscape. It really is quite labor intensive the more and more cubes that you get. Something else I will point out while we're just looking at this, you can see that there is a seam running down through here, through this Perlin Noise. Interestingly enough, the Perlin Noise function in Unity mirrors itself around 0. Okay, so this is the world 0, and you can see that it is a perfect mirror image. If we can look at it like that, you can see that it's mirroring out from there. If you don't want that, then basically, I guess if we go back over and move our landscape, we kind of want to be generating our landscape and our offsets for our landscape away from 0 as much as possible, and then you'll find you don't get any of that mirror action happening at all. Now, I said also that we are able to move our landscape. If you click on the landscape and grab hold of its axis, you'll also be able to slide it over that Perlin Noise function. So it's kind of acting like a revealer for this invisible wave that is extending forever in every direction in your 3D environment and finding where its sort of mathematical value is sitting. Okay, and you can see it's really nice. Now you've got it to this kind of point, you can play it again but ramp up the width and height. So if we make it like 200, 200 and 3, I know this is going to start to slow things down a fair bit. You will run out of processing quite quickly with it. So here's a nice big landscape that I can zoom out. I can already feel the lag going on in here. If I try and grab that landscape and slide it along, yep, you can see I'm going to have issues with it. It's still working. It's not as smooth as it was because it's doing an awful lot of processing for all of those layers over all of that width and height. Now, if you want your landscape to wave on the spot, so not actually have to move it around, we can make a few really quick changes that also demonstrate the way that you can modify meshes if you wanted to create like ocean waves. This is exactly the same method. First of all, what am I doing here? I'm going to take away the ability of moving our landscape's X offset. So I'm going to take the X and put it outside, the X offset, and set it to 0 initially there. And then down inside of my update, I'm going to use the X offset. And each time we update, I'm going to add 1 to it. So it's going to give the effect each update of moving the landscape across the 3D environment. But I don't want it to actually move in the X direction. I do want to use the X offset to calculate the height, but not to move it. So down in the positioning inside of our for loop, I'll just take that X offset out of there like that. The rest is the same, and it's still going to try and move because of this code here. But as long as you don't use the arrow keys, it's not going to bother you, but you could take that out if you wanted. So save that, switch back. I'm going to go back to my landscape because we left it pretty heavy with those 200s. Let me go back to 100, 100, and a layer of 2. And then let's just press play. We'll now see, getting closer, that we've got the same scrolling action happening, but the landscape's not going anywhere. So what we'll do is you will use this as a basis for improving on the optimization as we add more and more cubes so that we don't need to keep just moving around that landscape. All right, so I'll leave it there. I know I still haven't covered that job system. I'm getting to it in the next video. Now that you've got this, we're going to start looking at the profiler, at exactly what's happening, and then we're going to bring in that job system and improve the performance. Thanks for watching. Please support the development of more superb online learning content by subscribing, and as always, visit holistic3d.com to learn more about awesome games development books and tutorials.